Welcome. So in this part, we're going to be going through the following examples in which a common factor of x can first be taken out. So this is what we have. We have to solve this. Now, this is a bit trickier to what we've previously seen. So up here, we were asked to solve this, and it was already factorized for us, which meant we just had to use the null factor theorem, nice and easy, to solve it. But the reason why it was so easy is because it was already factorized for us. As you can see, this is not factorized for us. We have to factorize it first before we can solve it. So the first thing that we need to do is we need to factorize. Now, when you're factorizing, you always want to see if you can take out a common factor first. And as we're told here, we can take out a common factor of x first. So let's do that. We're going to take out x, and that's going to leave me with 2x squared minus x minus 1 is equal to 0. Then I need to keep on factorizing here. So now I need to say, well, I need a number, because I've got a coefficient of my x squared is 2 times negative 1 is negative 2. The sum is going to be negative 1. What are those factors going to be? Well, it's going to be negative 2 and 1, because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So that means now what I'm going to do is I'm going to go, this is x, and then I'm going to go 2x squared. And now I'm going to rewrite this negative x as negative 2x plus x because of these factors here. So negative 2x plus x, then I've got this negative 1 here, is equal to 0. So as you can see, I'm factorizing here. Then the next thing that I'm going to have to do is I'm going to say, all right, I have to factorize these. So we should all know how to do this. What we're going to end up doing is we're going to take out 2x here, and that's going to leave me with x minus 1. And then here, well, I want x minus 1, and it's already that, so I'm just going to take out 1. That's going to leave me with x minus 1 here. And that's going to be equal to 0. And then the next thing that I can do is as you can see, I have x minus 1 and x minus 1, and that's what we want, because now I can take that out as a common factor. So I can go x minus 1, then 2x plus 1 is equal to 0. And now it's factorized. And now that it's factorized, I can just use my null factor theorem. So I can set this and this and this all equal to 0. So x is equal to 0, or x minus 1 is equal to 0, or 2x plus 1 is equal to 0. So that means x is going to be equal to 0, 1, or negative a half. And that's how you do that question. So it's really important that you are first factorizing it. And whenever you're factorizing, you want to see if you can first take out a common factor first. And that's what we did. So unlike our first example here, which was nice and easy because it was already factorized for us, with these ones, you have to do the factorizing yourself. And it might get a little tricky. You have to make sure that you're good at factorizing quadratics for some of them as well. Let's come over here now and see if we can factorize this over here. Now this one is even trickier again, but yet again, the first thing that we're going to have to do is we're going to have to factorize it. So before you can solve it, you're going to have to factorize it, because only then can you solve. Now, the first thing you're going to look for is if you can take out a common factor, and you can take out a common factor of x. So that's going to leave us with x squared plus 2x minus 10 is equal to 0. And then what you might try to do is what we did over here. So you might go, my product is going to have to be negative 10. My sum is going to have to be 2. What are my factors going to be to make this possible? And quite clearly, it doesn't work. So you might be thinking, can this be factorized at all? And just to kind of prove to yourself that it can be, you'd look at your discriminant. So that, b in this case is going to be 2, so it's going to be 2 squared minus 4. A is 1, and c is negative 10. So that means I'm going to get 4 plus 40 is equal to 44. So it definitely can be factorized because I've got a positive discriminant, but it just can't be factorized in this way. So what are we going to do? Well, we've got two options. We could either complete the square, or we could use our quadratic formula. Two methods that is assumed knowledge. You should be very comfortable with both of these. So I'll show you both, and then you can kind of pick which way you like better. So let's complete the square. And remember, I'm completing the square just for this part here. So that means this x out here stays just like, it just stays there. It's just hanging out there. So I'm going to go x squared plus 2x. And remember, you take the coefficient here, you halve it, you square it, then you subtract it, then you minus the 10 that you've got there, and this is all still equal to 0. Then I'm going to go x. Now, the next thing that you're going to do, remember, you're completing the square, so the whole point of this is this part right here is a perfect square now. So that means I have x plus 1 squared. And let me still put all this in brackets, because then this part right here is going to be what? It's going to be minus 1 minus 10 equals 0. And then I'm going to get x. This is going to be x plus 1 squared. This is going to be minus 11 equals 0. Okay, so we're doing well. Then once I'm here, so I've got it in this form right here. Now this is fine, but I need it to be more factorized. So I don't like it to be like this. And there's actually another way that I could write it that makes it look more factorized. And you may have seen this before. What I can do is this. So I've still got this x out here. I can do this. I can go x plus 1, and then I can take this, and I can say minus the square root of this, then close that bracket, open it up, and then go x plus 1 again, and then go plus the square root of this. And now it's factorized. It's perfectly factorized now. If you want to see why this step is possible from going from here to here, expand this out. And what you'll see when you expand it out is you arrive back at this. So this is perfectly acceptable, and it's just something that you should commit to memory in terms of how to do it. So if you have x plus 1 squared plus or minus something here, you can go plus or minus the square root of that thing to get it into a form that looks like this. It's nice and factorized. And this is from example 17 in your textbook, if you want to refer to that as well. Then what you're going to do is you're going to set each of these equal to 0. So you go x is equal to 0, or you could set this one equal to 0. So this would be x plus 1 minus the square root of 11 is equal to 0. Or x plus 1 plus the square root of 11 is equal to 0. So that's that one right there. Then, after doing that, you could say x is equal to 0. Or, in this case, I would move everything on to the other side. So it would be negative 1 minus the square root of 11. And then over here, it would be negative 1. Oh, sorry, this would be plus, and this would be minus the square root of 11. Because you're moving it over. Perfect. So that's how you would do that. So that's how you do it by completing the square. If you wanted to, there is another way you can do it, and I can show you. So let's now come over here. So the other way that you could approach this question, if you didn't want to complete the square, so this is, we can say this is option 1. The other way you could do it is your quadratic formula. So what you would want to do is you've got x squared plus 2x minus 10 is equal to 0. And you could immediately say, just based on this x here, that one of your answers is going to be x is equal to 0. You know that because you just got an x hanging out there. So you just need to use the quadratic formula for this part here. This is what you need to use the quad formula on. Because you already know one of them. You already know that x is going to be equal to 0. Okay, so you'd go the following. You'd go minus b plus or minus the square root of b squared minus 4ac over 2a. B is going to be 2. B is going to be 2 here, so it's going to be 4. Then I'm going to chuck in 1 and negative 10, which is going to make this plus 44. Sorry, plus 40. Getting ahead of myself. So that's just by subbing it in, so nothing too tricky there. I might need to move this down because I'll need more space. Then I would go, oh, and sorry, this a is just 1. So it's just be 2 there. Then I can go negative 2 plus or minus the square root of 44 on 2. Let me just get rid of this because I'm going to just keep moving it down. This is going to be negative 2. Now, I can go plus or minus. This can be written as 4 times that on 2, in which case I can go negative 2 plus or minus 2, the square root of 11 on 2. Once I'm here, I can now go, well, this will cancel with this to make it 1, and this to make it 1. So that means what I'm going to end up with here is -1 plus or minus the square root of 11. And remember, this is what x is going to be equal to. So that means at the end of all of this, we know that x is going to be equal to 0, and we know it's going to be equal to -1 plus the square root of 11 and -1 minus the square root of 11. So that's how you'd use the quadratic formula to do this. So as you can see, you get the same answer as you did over here: 0, -1 plus the square root of 11, -1 minus the square root of 11. And that's how you would approach it. So pick your poison as to whether or not you like the quadratic formula version or complete the square version. But that's how you would do these questions here. So the moral of the story is that you're factorizing, and then once you're factorizing, you're then solving it. So using that null factor theorem that we spoke about in part 1. And you just need to make sure that you are comfortable with factorizing quadratics, or if you need to complete the square if necessary, or using the quadratic formula if necessary. Lots of things that you need to make sure that you're on top of, and a lot of this is just assumed knowledge from last year. So make sure that you're brushing up on it if you are confused with it. I'll stop this, and in the next one we'll go through some more examples.